if r is not 1, well, we really want to know about these partial sums, this s sub n. So I'm going to add up the first n terms, a times r squared, a times r, n minus 1. Okay. So what I'm going to do is I'm going to take this equation, there's this kind of trick I'm about to do. I'm going to multiply this whole equation, multiply by r. r s sub n equals, and I'm going to multiply all the terms by r. So now I'm getting ar for the first term, I'm getting ar squared for the second term, ar n minus 1, and the last term I'm getting a times r. Okay, you multiply every single term in that equation by r. So I now have two equations. What I'm going to do is I'm going to take equation 1, the top one, and I'm going to subtract equation 2. So you're going to take, what I'm going to do is I'm going to take and subtract 1 and 2. What is that going to give me? Well, on the left, what am I going to get on the left side of the equation? S sub n minus r s sub n. That was the left. And then on the right, I'm going to get a, but notice I've aligned these on the right-hand side in a very nice way. You're going to get a sub r minus a sub r. So that's going to be 0. A sub r squared minus a sub r, ar squared, sorry. So these cancel, these terms in between here are going to cancel, and I'm just going to get ar, the n term, plus a minus ar, because I was subtracting. Do we all see that? Yeah? How are those 0? Because if you look what you're doing here, I'm having a sub r, and then there's this minus sign, minus a sub r. Do you see that?
Okay.
So I have a sub r minus a sub r. Why do I keep saying sub? Sorry. AR minus AR. That's 0, right? AR squared minus AR squared. That's 0. And you keep going down. So they're matching up. And because they're matching up, when I subtract them, they cancel. Just like when we did long division, right? When they matched up and we subtracted, they canceled. Yeah?
Okay, so it's just a matter of lining them up and then subtracting.
And then, yeah, exactly. But this formula is a lot nicer, right? I wanted to solve for, I want to have a nice formula for S sub n. So my goal right now is to solve for Sn. So how could I solve for Sn? All the S sub n's are on the left side, right? So if you were solving an equation like let's say x minus 2x equals 4, what would you do if you were solving for x? You would combine these, right? Or another way to explain that is you would factor out an x on the left-hand side. So let's factor out over here, let's factor out S sub n. 1 minus r what would you do if you wanted to solve for Sn? Divide. Dividing is kind of a tricky process. There's one number we can't divide by. What's that one number? 0. So here's why it's important that we said r can't be 1. Since r is not 1, 1 minus r is not 0. So I can divide now by this 1 minus r because r is not 1. So I solve for s sub n, and I'm going to get a minus ar oh, sorry, this should be r to the n. It should be an n there. So the last thing I'm going to do to make this formula look a little bit nicer is I'm going to factor out an a out of the numerator. And this is my formula for my partial sums. Which, remember, I said you can't always get a formula, but in this case for a geometric series we can. Okay. All right. Can we do what? We're gonna do an example in just a minute, but I want to know, this is my formula for s sub n. I want to know, now that I have a formula, if the series converges. So I need to take this limit. So what I want to do is I want to take the limit of s sub n. So a 1 minus rn over okay, let's distribute the a. Again, I'm going to distribute it so that I'm going to split it up into 2 fractions. Into the fraction a 1 minus r okay. If you're looking at this first limit, the first fraction, there's no n in that expression at all, right? Do we all agree that there's no n there, the first fraction? A and r represent fixed numbers. A represents the first term in my sequence. R represents the ratio, the number I multiply by to get my next term. So the limit of a constant, what's the limit of 1? 1. So the limit of a over 1 minus r, what's that limit going to be? A over 1 minus r, right? A over 1 minus r. So now what I need to do is I now need to look at the limit of this last piece, a r to the n over 1 minus r. So let's go ahead and pull out the constants. A is a constant and the denominator is also constant, so let's pull those out. So minus a over 1 over r. This limit, r of r to the n, we saw this limit back at the end of talking about sequences, right? We spent a bunch of time talking about this limit, and this is exactly why. I need to know what this limit is. So remember there are conditions on r. If r is between -1
-1
and 1, it converges, right? So I now know that if r is between -1 and 1, r to the n, we've said goes to 0 as n goes to infinity. And remember, we're still under the assumption r is not 1. So that's why I said between -1 and 1, not including 1. So that limit converges, right? I would get 0 for that limit. So what this tells me is that my geometric series, so let me sum this up as our now overall statement. The geometric series AR r to the n minus 1 converges if the absolute value of r is less than 1. And its sum is a over 1 minus r. Because that limit is 0. Okay? Otherwise, it diverges, okay? So if the absolute value of r is greater than 1, greater than or equal to the series n equals 1 to infinity, a r to the n minus 1 diverges. Okay? This is the part that I want you to take away from what we just did. Okay? This is the overall statement that you're going to need to remember. This tells you exactly when a geometric series converges, and it tells you exactly when it diverges.